never show an audience any equations. That was sage advice given to physicist Stephen Hawking. So, forgive me if I show just one, as follows. 1 plus 1 equals 2. Everyone would agree. But if this is an equation of physics, we should ask, does it describe true reality? Could it represent the fact that a uranium nucleus bombarded by neutrons can split into 2 or more parts? Could it represent the 30th of October in 2024 when a Hellfire missile split a speeding orb into smaller parts? The goal for physicists is to determine if reality is behind the equations. That's what matters. Take, for example, the strange case of Sir Isaac Newton, who developed his famous equation describing gravity as a force. Just a quick look at the formula tells us it was used to calculate the force F, and although it could be applied to the apple dropping from a tree, it also applied to planets and their orbits. And it was almost perfect for that. However, something bothered Sir Isaac. You see, this force appeared as an action at a distance. Even Newton did not believe that. In a letter to a friend, he said as much. Quote, "So great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it." And there was another problem. The orbits would not obey the equation. Take planet Mercury, for example. It shifts its orbit ever so slightly every time it comes close to the Sun. The amount of shift was tiny, but it was there. Astronomers of the time thought perhaps an unseen planet was influencing Mercury. They named it Vulcan, even before they found it. In fact, they searched and never found it. They had to admit it wasn't there, which meant Newton's formula was off a little bit. As happens in physics when theories are not working, a new theory came in. Albert Einstein in 1915 proposed his theory of general relativity. Rather than focusing on the terms of the equation, let's just call it his. It's not a force equation. Or, even better, we can call it his. It's a curved spacetime equation. Basically, instead of requiring that a force reach across the millions of miles from the Sun to the Earth, Einstein was saying the Sun influenced the space in between to curve. That way, when the curving of space reached Earth, that would cause Earth to revolve around the Sun in the manner we see it does. And Einstein's equation was almost perfect. However, issues began to appear. The outer stars of spiral galaxies moved faster than Einstein's theory specified. Plus, the theory did not predict the universe as expanding in an accelerating manner, as scientists believed it does. And there were infinities that caused problems. So, a new theory came in. It was called Lambda, cold dark matter. It took all of Einstein's general relativity in but added things. For example, it added lambda and dark matter that was cold. Unlike Einstein's general relativity equation, which was not a fitted patch, the Lambda-CDM approach was to numerically fit the equation to the data. Sort of like marking your exam paper from a list of all the right answers. But when they were finished, all the patching had left the Lambda-CDM theory with 95% of the universe added on to make the numbers come out. But again, no one could find all that dark matter or dark energy. Naturally, this problem invites other scientists to propose a competing theory. The space phase theory, also called SP3, concentrates on explaining the universe we can actually see. The space in between planets and stars, also called empty space, that actually has something in it, space phase. This so-called medium or substrate has specific features that help keep our universe on track. It guides matter, such as planets and moons and galaxies. It transports energy such as light and radiation. That guidance occurs because space phase can stiffen into invisible paths called coherence corridors. Just like water vapor can condense into rain, space phase can sometimes condense into matter, such as elements and comets and stars. The good news is that all the systems of equations from standard physics are accepted within space phase. That's because, even though the original researchers developing those equations did not know it, the space phase was in the room participating while they mapped out their experiments. The space phase theory holds that space phase acts at all scales, from inside the atom to across the cosmos. Many new discoveries which standard theory does not address are explained by space phase, such as spiral structures at the horizon of black holes, and even the incident where a U.S. drone Hellfire missile hit an orb off the coast of Yemen in 2024. Frame-by-frame analysis of the video demonstrates an orb was speeding along across the surface of the water without any visible means of propulsion, no propeller, no jet engine. The missile hit the orb but bounced off, according to witnesses. The impact led to the orb delivering several smaller orbs, but instead of taking a ballistic course, these smaller orbs returned to formation behind the main orb, and together they continued in their same original path along what space phase theory calls a coherence corridor. Perhaps this new space phase theory is just what the professor ordered. Harvard physics professor Avi Loeb was recently quoted as saying, "Physics today is stuck and needs a new Einstein to provide another revolution in thought." This could be the beginning of just such a revolution. Plus, for your own inquiring mind, don't you owe it to yourself to have a look? Inside these pages, you will find answers and amazing new details. Plus, if you are an educator, the scientific reasoning course is perfect for helping both your STEM and professional students to think like scientists and reason based on the facts. The 21st century in science has arrived. Be among the first to embrace it.